Okay, today it's all about the arithmetic sequence. It says it's called arithmetic because it's in adjectives. Okay, arithmetic is the noun. All right, so find the common difference, determine a formula, and to determine a formula for the sequence. So if we want to find the ninth term of the following sequence, take a second. You should be able to do that today. Okay, this one here, the ninth term should have been 96. It was 91. You went down by 3, so then it was 88, 85, 82, 79, 76. As long as I subtracted right. And this one went up by 5s. So the ninth term should be 55. Okay. What if you had to find the 40th term for this guy? Or let's even go with the 300th term. That would take you a really long time. I mean, you could go through it, but it would take a long time. So we have these formulas. Now, you should recognize them. You were supposed to have done them in Algebra 1. So this is a bit of a review in a small way. Okay, so what we have to figure out, we have to use this formula. Now, I often write it like this when I'm using the formula because this is just the way I was taught. But it just means when you put the D here, it's just you're multiplying that in. D, multiply it in. Remember, a sub n and a sub 1, that's the actual value of the term. So a sub, so this is almost like y, you could consider it. And then the subscript, that one's telling you your n's, or your x's. So try to get that in your head, and this shouldn't be too hard. Okay, D is your common difference. That just means, how did I get from this term to the next term? To find the common difference, we take one term and we subtract the one before it. So 11 minus 8. So the common difference here is 3. So it's always subtract the one before. So this 11 minus 8. The first term, a sub 1, that's 8. That's the first term. Okay, so that's like your y value, 1 being the x. And then a sub n, well, that's the formula. I don't have an n here. Sorry, our sheet doesn't have that. So a sub n is, let's use the formula. So it's a sub 1, that's 8, plus, well, n. This number and this number should always match. So if this is an n, this is an n. Minus 1 times the common difference. If you put the 3 on the other side, it doesn't matter. So to figure out this formula, it's 8 plus 3n minus 3. Combine these two, combine like terms, so it's 3n plus 5. So a sub n is 3n plus 5. So now, if I want to find the 400th term, I'll simply just put a 400, and I would plug 400 in, and it would give me that. So that's the difference between a recursive formula and an explicit formula. So the explicit formula makes it very simple for us. Given this, the explicit formula, whatever term we want, we just plug it in and get an answer. With recursion, we have to find all the ones before it. So to find an explicit formula, or determine the nth term, these two things mean the same thing. We want to figure out what a sub n is. Okay, so to do that, first we need the common difference. That's the first thing you look for. Then you need your a1, and you plug it all in and you get your formula. So the common difference here would be 6 minus 3. You could subtract any of them. You could do 9 minus 6, 12 minus 9. It'll always be the same. The first term is 3, so we just plug it in. 3 plus n minus 1 times 3. So it'd be 3 plus 3n minus 3. So it's simply just 3n. So if I want to find the 90th term, I just plug in 90 for n. Okay, try this one on your own, and we'll see how it goes. Okay, with this one, the common difference is negative. Remember, it's always 1 minus the one before it. So this one is negative 2. The first term is 18. We plug it all in, doing the math. Negative 2n plus 20, because it's going down, so this one would have a negative slope. Alrighty. For this one, a sub 1 is 8, a sub 7 is negative 10. You want to find a sub 23. Okay, so the way that this works is we have to still do the same thing. We need the D, We need the A1. Oh, we have that. And then we want to find we want to find the 23rd term. So we don't need the explicit formula, we want the 23rd term. Okay, so common difference is different here. Now you may be able to figure this one out on your own because you're smart people. But I like to use the formula to do this. So instead of not having a sub n, we have a second term here. We don't have the common difference. So when we use this formula, a sub n equals a sub 1 plus n minus 1 times the common difference, this is the only thing we don't have now. So a sub n is going to be our a sub 7. A sub 1 is a sub 1. N, remember this number and this number always match. That should be 7. It's just big this time. It's not a subscript. And that's D. So let's plug in. This is like our Y. A sub 7 is negative 10. 8. What is that? 60. And we solve the equation. Right. So this is minus 18 equals 6D. Divide by D. Oh, yeah, divide by 6. Sorry. And you should get negative 3. So your common difference is negative 3. And it makes sense because you're getting smaller as you go higher. So it should be negative. And then you just have to figure it out. Some of you can do that in your head because you're smart guys, but, you know, I'm not. Okay, so now we use the formula. So again, we use the formula a sub 1 plus n. So remember, this is n. Minus 1. Now we know the common difference. We multiply that times negative 3. Now let's plug the things in that we have. We don't know A23, but we know 23. So A sub 1 is 8 plus 22 times negative 3. So just do all the math. And you should get negative 58. Okay, let's try the next one, and I'll try not to hit so hard. So here we want to find the explicit formula, so that's the same idea, but instead of A23, we want A sub n. So that's what we did on the front. So why don't you give that a try and see what it looks like. Okay, the first thing that you need is that common difference, so I plugged the 2 points in that I knew, leaving the common difference as D. Okay, I plugged 10 in for A4 and 4 in for n. 1 in for A1, did the math, and I got 3. Now that you know the common difference, this is 3. You know A1 is 1. Now what's the formula? Okay, so the common difference the common difference was 3. So the formula, you plug that in, but you leave a sub n because that's the explicit formula. And you should get 3n minus 2. Okay, on ours, we then ask for a sub n. If that equals 52, what do? What term is it? What is n? So in this case, they're kind of giving us y. So when they're giving us y, we simply have to plug that in the appropriate place. So technically in our world, that's like our y. So we put a 52 in there, and we want to find out what n is. Okay, so then you add your 2. So it's 54 equals 3n, divide by 3, and n should be 18, again, as long as I did that right. All right, so now this is kind of a real-world situation. Jorge has 40 bucks. There you go, Jorge. He plans to save $15. I feel like I'm 3D movie here. Save $15 a week. So he already has 40 bucks. Great. So on that first week, he saves $15. So he should have $55 after that, on that first week, once that's over. So that's our a sub 1. The common difference is how much he saves every week. What's the difference every week? Well, that's 15. He saves $15 every week. So then we just simply use our formula. Write a formula. So a sub n would be the formula, where n is the number of weeks. So then a sub 1, we said, was 55. N minus 1, we don't know what n is, and we know the common difference. Distribute that through. A sub n equals 55 you know, whatever, you can solve this. And then combine, so a sub n is 15n plus 40. So on week 30, we could plug in and we could figure out how much money he should have saved as long as he doesn't take anything out. With this one, we want to know how long it would take him to get $190. So that's our y. It's not our n. They're not saying in 5 weeks. So remember, n is the number of weeks. So this one is the money. So it's this a sub n is your money, n is your time. So you have to get used to that. We've done that a lot with, you know, regressions and things like that. So 15n plus 40, and you simply solve. 150. So n is 10. So it should take 10 weeks to get $190. All right, have a good day.